In this video, we're going to discuss the normal distribution. A normal distribution represents populations or groups of data where most of the values are going to be near the mean, and the farther away you get from the mean, you're going to run into fewer and fewer values. An example might be men's heights. The average height is about 5'10" for men. So most men are going to be within 2 or 3 inches of that 5'10". As you look at heights a lot taller than that or a lot shorter than that, you're going to find fewer and fewer people. You can represent it with this shape of the normal curve. It's symmetric with one hump. If you remember from before, we used the Greek letter mu to represent the mean. So I'm going to use that in the middle. So that's where the middle of our data is. So it's also the median in this case. And it's symmetric, so there's a mirror image on each side. Also, if I go out 1 standard deviation from that in each direction, turns out it doesn't matter what your mean and standard deviation are. That's supposed to be a minus 1 standard deviation. Let me erase that. There we go. If I go out 1 standard deviation in each direction, I'm going to get 68% of my values in a normal distribution. So over 2/3 are going to be within 1 standard deviation. If I go out a 2nd standard deviation, I'll do this in blue, from the mean, I'm going to get almost all of them. In that case, I'm going to get 95% of the values are going to be within 2 standard deviations, which means you only get about 2.5% then on each, we call it the tail, right, to the right. If you go out 3 standard deviations, there's very, very few values that would be more than 3 standard deviations, greater than the mean, or less than the mean. So let's look at an example. It might help sometimes putting in actual numbers. So let's look at IQ scores. IQ scores are from a normal distribution where the mean is 100 and the standard deviation is 15. So let's label our x-axis here. Since the mean is in the middle, there's our 100. If we go up 1 standard deviation, that's 115. Go up another standard deviation is 130. Go down 1 standard deviation, it's 85. Go down another, that's 70. All right. So the question is, what percent of scores are between 85 and 115? So here's our mean right in the middle. Well, the 85 and the 115 happen to be that plus or minus 1. So that's that 68% that we were talking about before, within 1 standard deviation. So we know that 68% of IQ scores are going to be between 85 and 115. The next question here is, what percent are between 70 and 130? Switch colors again. Well, that's out plus or minus 2 standard deviations. And like we talked about before, that gives you 95% of your population. So it turns out 95% of IQ scores are between 70 and 130. There's only about 2.5% then of IQ scores greater than 130 and 2.5% less than 70. Let's look at a third question. What if I want to know what percent are between an IQ of 94 and 121? All right, this causes some trouble because here is, scroll down a little bit, 94 in here somewhere. I'll kind of do a rough drawing here somewhere. All right, not going to be perfect, but so there's about the 94, the 121, that's in here somewhere, right? So I want to know what's in between here. I know it's a lot of scribbling on this, but well, that doesn't fall on the 85 and the 115, the 130, the 70. So for now, that's a big question mark. And that's going to be our goal. How do I answer questions like this? Well, in order to do that, we need to be familiar with a very specific normal distribution, which is what's called the standard normal distribution. So the standard normal distribution has a mean of 0 and a standard deviation of 1. So I'm going to go back to my red pen. So that means the mean in the middle we have is 0. If I go up 1 standard deviation, that's 1. If I go up 2 standard deviations, is 2, 3, and then as I go down, 1 standard deviation is -1, -2, -3. So notice each of these values on my x-axis represents how many standard deviations we are above or below the mean. And that might sound familiar if you think back to what we did with z-scores, right? Z-scores also represented how many standard deviations we are from the mean. So it turns out that's what we're looking at here, are really our z-scores. But we'll come back to that later. But let's look at some problems now where we use the standard normal distribution. That'll come in handy. To look up these values, we're going to have to use a table. So here is a z table that has z values, and you look up the value and it will tell you what proportion is less. So this, normally this is on the table. Let's take it off this one just for space reasons. But this table always tells you what percent is less. So it gives you this part of our curve to the left. So these are all, this table has all negative z-scores, you'll notice. So those will all be less than 0. There's a second half of the table that does the same thing. But notice these z-scores are all positive. So they're going to give us the values, z values greater than 0. So if I do my little curve here, kind of sloppy, but so these values will be to the right of 0, but it's still, the number represents what's less. So it's going to be still to the left. And that's going to be important when we look up some of these numbers. So let's look at an example of how we can use this table. So number 1 here, what percent of scores are less than a z of 0.83 on the normal distribution? Now you don't have to draw the little sketch. I always like to do this. It helps me visualize exactly what I'm looking for. If you do a sketch, it doesn't even have to be neat. This one's kind of sloppy. But 0.83 is bigger than 0, so that's to the right of 0. And I want to know what percent are less. So that's to the left of 0.83 on my curve. So to find that number, I'm going to look up 0.83 on my table with positive z-scores. So let's go to this table, zoom in a little bit maybe. And hang on a second, I'm going to erase some of this other scribbling on here. All right, so 0.83. So the left-hand column here gives me to the 10th. So I got the 0.8, and then the row across the top is the 100th. So 3 is in the hundredths. So I'm going to do the 0.03, so that's 0.83. So it's this number here. I hope you can read that on the video. 0.7967. So it's telling me that this is 0.7967. So these are all probabilities. If I convert that into a percent, that's telling me that 79.67%, or almost 80% of values are less than a z-score of 0.83. So right now you may look at these z-scores and say, well, I don't see how this is going to help us We'll get to that eventually, right? We're going to put all this together, the z-scores and the normal distribution, next time. So for the time being, we'll just focus on excuse me, the standard normal. So the next one is what percent are less than a z of negative 2.13? So this is a negative z. So if I do my little sketch here, here's my 0. This is to the left. Negative 2 is quite a ways to the left. If you remember, there wasn't much less than that. So we're looking at this part. So this is going to be the negative z table, 2.13. So I'm going to scroll up here to the negative table. And we're going to look at negative 2.1 and then 3, so it's at 0.03 again. So negative 2.13 gives me 0.0166. So 0.0166. So scroll back down. 0.0166 is what my table tells me, which as a percent is 1.66%. So aren't too many values less than a z-score of negative 2.13. So now, what if instead we wanted to know what percent of scores are greater than a z of negative 2.13? What would we have done? All right, so let's just take a look at what we had just did, right? Negative 2.13. Let's say instead we want this part of our curve. We want to know what's to the right. Well, we know to the left is 0.0166. Well, the probability of the whole thing is going to be 1, or 100% of the values. So to find the greater than, we're going to have to subtract the 0.0166 from 1. And that's what 0.9834, or as a percent, 98.34%. So you'll notice if you have the worksheet printed out at the bottom, there's a little table telling you what to do in the different situations. So let's look at one of these from the beginning now, where we have to subtract from 1. What percent of scores are greater than a z of 1.63? So, little table to help as my guide. Here's the 0. Here's the 1.63. And the question on this one is greater than. Well, if I look up that number on a table, it's going to give me what's to the left. So let's do that first. So 1.63. So here's the 1.6. And I know you can't see the top of the column here, but this is 1.60, 61, 62, 63. So 0.9484. .9484 is this part to the left. That's not what we're looking for. So you have to read these questions carefully. We want greater than, so we have to subtract that number from 1. So 1 minus 0.9484 is 0.0516. So that's 5.16% of values are greater than that z-score. So less than, you look the number up on the table, we're all done. If it's a greater than problem, you have to look it up on the table, then subtract that value from 1. And we have one last situation, and that's the between. So let's say we want to know what percent of scores are between 0.35 and 1.74. So these are both positive. So we have our 0. So this will just be, again, a rough sketch. It's just going to help me visualize. But I got my two z-scores are both greater than 0. And I want to know what's in between. Well, what I can do is look up the 1.74 on the table, which will give me everything to the left of 1.74. Look up everything to the left of 0.35 by looking up that value. So if I take this blue part, subtract the green part, I'm going to be left with this part in between, which is what we're looking for. So what I'm going to do is look the two values up on the table first and then subtract those values. So make sure you do the table before you subtract. That's a common mistake. Students will subtract the z-scores instead. So 1.74 was the larger of the two. So let's go to here and let's erase some of this mess. All right, and it was 1.74. So here's the 1.7, and then it was 0, 1, 2, 3, 4. That column. That's the 0.04 up here. So 0.9591. So there's gonna be lots of scrolling on this. I've already forgotten what I said. 9591. .9591. That's that blue one. All right, let's subtract off the same thing for 0.35. So let's go back to our table. 0.35. All right. Again, let me just get rid of some of this we had before. I'll do this in green. So 0.3 and then 5 in the hundredths is going to be 0.6368. And scroll that down. 0.6368. 0.6368. So if I subtract those two, I'm going to get there what's in between, which is what we want. So you look the two numbers up on the table, then subtract the table values. And what is that? 3223. So it's 32.23% are in between those two values. So here's a summary of what we've done. And hopefully this is enough to get you through the practice on this. Make sure you go to the packet and look up the problems and practice these using the z-table, because next time we're going to combine finding z-scores with using this z-table to find answers to questions. So if it's a less than problem, you just look that number up on the table and you're all done. If you're looking for a probability or a percent that's greater than a number, you look that up on the table, but then you have to subtract that number from 1 to get the greater than. And then this last one, if it's between the two z-scores, look up the two probabilities on the table separately and then subtract the probabilities from each other. Make sure you look them up on the table first. So now back to our question. What percent of scores are between 94 and 121? All right, well, we're going to do that next time. So in class, we'll actually get to that piece of the puzzle. So we'll look at how to find the z-scores for each of those values, look those up on the table, and then subtract from there. So hopefully that's enough to get you through the work on the using the probabilities of the z-scores. And Next time we'll take it from there. So in the meantime, have a great week.